Hello, I'm Louis Immersheim, Principal Product Manager at Red Hat. And with me today, I've got Amit Khandelwal, a Senior Program Manager and for Data Platform for SQL Server at Microsoft. And today, we're going to talk to you about reducing administrator support and maintenance time with Microsoft SQL Server 2022 and Red Hat Enterprise Linux. Now, Microsoft 2022 is the latest release of a long line of SQL Server releases. In fact, over 25 years, I think we're now at 20. Are we at 28 years now, Amit, of SQL Server?
Yes.
Yeah.
More than that.
So that's exciting. Yeah. So we know that a lot of customers are using SQL Server on Red Hat Enterprise Linux, and we know that there are even more customers who are very interested in it. And so we want to give you an update on SQL Server 2022 and some of the features that are new to Red Hat Enterprise Linux with RHEL 8.7 and RHEL 9.1, which are also the latest releases. So we're going to talk a little about both as we move through this presentation. So let's get started. I kind of started this by looking back and saying, hey, there's been SQL Server for 28 years. But, we also have customers who are using SQL Server. One of them is XM, who is an energy company down in South America. And you'll notice that one of the key benefits that XM found when they adopted SQL Server on Red Hat Enterprise Linux was that they were able to reduce their administrator support and maintenance time by 60%. And that's really what this whole discussion today is about, because we're really focused on reducing administrator support and maintenance. And here's a demonstration of how that has, of the results of that from one of our customers. So as we move on here, and of course, we're not just talking about Red Hat Enterprise Linux here. We're also talking about Red Hat OpenShift. So it's really important to remember that both platforms are supported by SQL Server. And that there are different deployment methods, actually, or SQL Server is packaged in different ways, specifically that work well with both of those environments. So, for example, traditional RPM packages you can install on RHEL. Containers you can install on both RHEL or OpenShift. You can run VMs, that are Red Hat Enterprise Linux VMs. You can actually run those on Red Hat OpenShift through Red Hat OpenShift virtualization. We also have, some other areas such as Microsoft Azure SQL Edge containers and Arc-enabled SQL managed instance containers that are available on these platforms as well.
Yeah, and we'll look about these RPM packages in the coming slides as well.
Yes. So what are some of the Red Hat Enterprise Linux for SQL Server features included with the subscription? Now, this is really important because, we also have Red Hat Enterprise Linux for SAP Solutions, and that's a special product. But here, even the basic Red Hat Enterprise Linux subscription includes SQL Server features. And then you get more of those features as you add add-ons, such as Red Hat High Availability add-on. But you're going to get, outstanding compatibility. You're going to get availability and security focus. You're going to get great performance. And most importantly to the customer, you're going to see manageability at scale. And this is because we've simplified the installation and configuration of complex multi-server environments. And we've done that with Red Hat Ansible through, with Ansible automation through the Red Hat system roles that we'll talk about soon. We also provide Red Hat Insights. We'll discuss that a bit for really day two management. And finally, we do support identity management. The Red Hat Identity Management is supported for integration with Active Directory, and that works with SQL Server as well. We're not going to dive as much into that today, but we're really going to focus on this Ansible piece, and I'm actually going to do a demo of that later on. So as we move on here, there we go. And it's important to realize that these same benefits come to the Kubernetes platform as well. So, for example, when we talk about performance, there are reference architectures that Amit's going to talk about later that will help you to get the best performance on an HP or Dell environment with Red Hat OpenShift. So that's a great example. And of course, all of this runs on Azure. And again, I'm not going to spoil Amit's thunder, right? But you're going to get stability and reliability within Azure. You're going to get high performance and availability, built-in security, strength and management, and of course, enterprise application support. And you'll get that support not just from Microsoft, but from Red Hat as well, because we have a joint support program for supporting SQL Server on RHEL or OpenShift in Microsoft Azure. So I mentioned Ansible before, and really Ansible is the de facto automation language. And it's become that because it's pretty simple. It's, a human readable language. It's really powerful because you can use it to span multiple domains. So there's lots of code out there that's already existing from commercial vendors, from open source communities, and even from Red Hat. We're going to talk about the Red Hat code here soon. And it's agentless, so it makes it really easy to deploy. Now, within Red Hat Enterprise Linux, we provide the Red Hat Enterprise Linux system roles. And they are a set of Ansible applications. So they're modules that you can use to deploy and configure various components of Red Hat Enterprise Linux. And if you look, there are a number of them that are subdivided into specific areas. There are ones that are focused on security, ones that are focused on configuration, and ones that are focused on workloads. And one of the ones that's focused on workloads, of course, is the Microsoft SQL Server role. So let's take a look at that role. And I'm actually going to give you a demo of it. The role was originally designed and released in RHEL 8.5, and it could install at that time and configure SQL Server. It would tune your storage layer. You could add in extras like SQL Agent, PowerShell, that aren't necessarily required in every deployment, but for some deployments, they're absolutely critical. And then you could also use it to manage connection security, because that's something that is managed by Active Directory in a Linux environment, or sorry, in a Windows environment. But on Linux, you need another way to do that. And so we made it possible for Ansible to do that for you. But
and just to give impact, sorry, Louis, to interrupt there, but just to give you an impact statement over here. I mean, someone like me who does this a lot, deploying SQL Server and Linux, testing high availability to ensure things are good. I was able to test this with Ansible script roles. I deployed 3 SQL Server VMs in Azure and deploy pacemaker, configure always on availability group, and also go ahead and add databases to the availability group. All of this took me just 8 minutes. So I ran the script, went, got a coffee, and everything was up and running.
And that's an example of the new feature functionality that we've added in RHEL 8.7 and RHEL 9.1, which is, of course, Amit sort of spoiled my thunder here. It's the always-on availability groups support. And that allows you to configure availability groups, coordinate with the high availability role that Amit mentioned, which managed Pacemaker, and then also manage AG certificates, which is another security thing that you might want to periodically update. And so you have the ability to do that through the role. And what I wanted to point out also is that, Amit was able to configure availability groups in just 8 minutes, but you can actually deploy a SQL Server, an individual SQL Server, in under a minute using the Ansible role. And I challenge you to try and do that on some of the other platforms that SQL Server runs on. So it can be a real time saver. So let's take a look at, I'm going to run you through an example of the role, and we'll go ahead and do that now. All right, let's roll the demo now. All right, so let's take a look at the Ansible playbook for Microsoft SQL Server. I'm going to do a demo today, and the first thing we're going to do in step 1 of that demo is install a SQL Server with a database. The second step, we will actually install and configure 2 additional SQL servers to replicate to. And in the third step, we will hook all of those SQL servers together in an always-on availability group managed by the by the Red Hat High Availability add-on through Pacemaker and ChorusSync. So first off, let's take a look at what we're actually doing here. You can see there's several scripts that I've created here in this directory. Several of these scripts the content comes from examples that are provided with the role, whether you get it from Galaxy, you get it from Ansible Automation Hub, or you get it through Red Hat Enterprise Linux. So let's go ahead and first look at this example DB script. And that script is just a T-SQL script that is creating a database, very basic. Now here we have the inventory, which is a list of the hosts that we are going to be operating on. And you can see we have the names of the hosts, MS SQL 1, MS SQL 2, MS SQL 3, and we have the replica type that's going to be applied. You'll see here's a primary, MS SQL 1. So the secondary will be a synchronous replica. And the primary would act as such if it were to fail over and become a secondary. And then the third type is a witness, which is essentially a configuration-only replica. This is a low-footprint replica. It can run SQL Server Express if you'd like, and its only purpose is to act as a tiebreaker between the other two nodes. So now we'll go ahead and move on, and we'll see step 1, where we are creating a SQL Server, and this will complete in under a minute. We're accepting all of our licenses. We're setting a password for the SA user, saying what type of SQL Server we want to install, in this case the Developer Edition, and then we'll run that create example DB script to instantiate a database, which we're calling example DB. Okay. In step 2, we're just going to configure 2 additional SQL servers, and we're not actually going to create databases within those SQL servers. Now in step 3, this is where the fun gets done with always-on availability groups. And you can see here we are setting up a, doing the basic things that you would do to set up an always-on availability group. We're opening a listener port on 5022 for SQL Server inter-cluster communications for the availability group. We're setting up private and public keys, which you do on Linux through scripts. On Windows, that's handled by Active Directory. So this whole process can be actually automated through the Ansible system role for Microsoft SQL Server. We are creating our endpoint. We're specifying that example DB is going to be the database that we are going to replicate. We are creating a Pacemaker login account because Pacemaker, as provided by the Red Hat High Availability add-on, is going to be the thing that manages our availability group and handles failovers. So we need to have a way for Pacemaker to be able to log in to our SQL Server. We will also take advantage of the HA cluster role to configure Pacemaker. So by saying that this is true, we're actually now moving into using configurations related to the HA cluster role. Here we're making sure our availability group name is also our Pacemaker cluster name. So that's really straightforward. We are setting up a password for the HA cluster. Let's see. And this is the password that will be used by the HA cluster account. We then go through and set up a bunch of cluster properties here. And really, I'm going to tell you, we're setting up the Microsoft resource agent for the always-on availability group. What I'm going to tell you here is that almost all of this you could just cut and paste from an example. We provide 3 examples. And those 3 examples show you how to set up a virtual environment on RHEL, or OpenShift virtualization, or Red Hat virtualization, in the first example, which is what I'm using here. There's an example for how to do the setup on Azure, And there's a third example for how to do it on VMware. So all of those examples are available, and we'll be putting more examples into the documentation as we go. In general, you're going to be able to just cut and paste that code because it, templates for you a lot of the basics behind configuring an always-on availability group with Pacemaker. So this last part is the Pacemaker-specific portion of the configuration. We're going to go ahead and run these now, and then we'll make sure that our cluster is up, and I'll show you how to do that with the PCS command. Okay, so we will first set up our initial SQL Server and its database. Here. All right, you'll see this is going to ask me for a become password, which is a password that I would use to become root on the system. So you do need to specify -B and -K options when running this role. There we go. And again, this will be done in under a minute. I'll time lapse it for us now. Okay, we'll do the same configuration on the secondary servers. But this time, again, we will not be adding a database. Okay, and now we'll configure our always-on availability group and associate that with a Red Hat High Availability cluster. All right, we're all set. So some things to notice from this configuration. Now, there are places where Fedora Linux system roles are mentioned. This is because I'm using the upstream version of system roles that comes from Ansible Galaxy that came along with the upstream version of the Microsoft SQL system role. Quite frankly, I'm using this because the role hasn't yet become available as we're doing this demo. It's coming with RHEL 9.1 and RHEL 8.7. The other thing you should notice is places where changes were made are marked in yellow. Places where those changes were successful is marked in green. Places where things were skipped is marked in blue, and anytime there's a failure, that's going to be marked as red. So, just some color identification there to help you track things down. Let's go ahead and take a look at the cluster configuration and see if the cluster is up. We'll do that with the PCS command. So I'll run PCS status, and it should show us information about the cluster. And as you can see here, we do have a cluster that is up. It is actually running on the virtual IP address associated with MS SQL 1. So the load balancer is, has is redirecting all requests right now to MS SQL 1, and the configuration replica and the synchronous replica are running as in the case of the MS SQL 2, it's running as a read-only replica, and in the cases of MS SQL 3, it's configuration only, so there's no data there. All right, that's our demo. Okay, so that's kind of a good overview of the always-on availability group support, as well as just the general system role. There's obviously some other options that we didn't have time to show you. And I should mention that while I did do this demo with the pre-release versions of the system role. The system role is now generally available in RHEL 9.1 as well as RHEL 8.7 at the time of this, that we're presenting this. So, just a little timing issue because we were down to the wire there for the recording. And so this kind of showed you day one configuration. What about day two? Okay. Day two, it becomes really important to find issues that might be occurring on a running SQL server. And you can do that with Red Hat Insights, which is actually has integration with the SQL Server Assessment API. And there's a great blog that I wrote that covers that. But a real key point about Red Hat Insights is that it also uses Ansible. And it uses Ansible for remediation. And in many cases, there are Ansible remediations for SQL issues. Where there aren't, there are T-SQL statements. So you can deploy this with either T-SQL or remediate either with T-SQL in some cases or Ansible in others. And in one case, using an Ansible remediation, we had an independent firm study, how much time they could save by using that Ansible remediation instead of a manual task. And they saw that it took 91% less time to address a vulnerability, which is a pretty amazing statement. So, with SQL Server. So it is super valuable, and you should definitely take a look at the Ansible piece. All right, at this point, I'm going to turn it back over to you, Amit, and we'll go ahead and move forward there.
Thank you so much, Louis, for the introduction to Ansible scripts and how easy it makes the task. Now, what I want to get started with is how easy it is for all of our customers to get started with SQL Server and RHEL. So in this section, what I basically want to focus upon is how easy it is for you to start in Azure with SQL Server and RHEL, or if you're looking to run something on-prem in terms of VM or bare metal, you also have RPM packages. Or if you're looking to start with containers, for example, if your strategy is to start with SQL Server containers running on Kubernetes platform like OpenShift, we also have pre-created or pre-configured container images that are made available. As you can see on the slide, basically it's all about where you want to run SQL Server and RHEL. Both the platforms are available for you to get started. For Azure, we already have pre-created marketplace images, which have the high availability packages for RHEL already pre-configured and installed. So when you go ahead and use that package, it basically comes with SQL Server, also comes with high availability packages. So it is easy for you to get started and configure high availability solutions like always on availability group or FCI. Similarly, if you want to get started with Kubernetes platform, and because some of you may be new to Kubernetes and you do not want to spend time managing it, administrating it, we have a managed version of Azure Red Hat OpenShift, which is running in Azure to get you quickly started. So if you're someone who's been working with SQL Server containers and pretty familiar with it, or someone who's been working with SQL Server on Windows and pretty familiar with it, you could just quickly get started with SQL Server containers on Kubernetes, and you can use pretty much the same tools that you've been using to actually connect and administer and manage the SQL Server. Similarly, if you want to run on-prem, we have multiple packages. A good news, we are also going ahead and shipping the RHEL 9 package pretty soon. The SQL Server 22 today is supported for RHEL 8, as well as the 19, the SQL Server 19 is supported for RHEL 7 and 8. And we will also be supporting the RHEL 9 as well. So these packages are also coming in soon. And one specific important note that I want to share with all of you is that these container packages, as well as the RPM packages, are all updated based on the same release cadency that we follow for SQL Server on Windows. So all the CUs, all the updates that you get for SQL Server on Windows on the similar cadence, on the similar dates is when you will see the updates coming in for both the container images as well as the RPM packages as well. And the pre-configured Azure Marketplace images are also basically updated. Now with that, if you're someone who wants to get started with SQL Server in Azure VMs, what are some of the important steps that you need to consider is what we'll take a look at in this particular slide. So the first things first is definitely you need to identify the right VM. For example, do you want to start with the the E series, the D series, or the M series, depending upon what your choices are. Then, of course, is the disk that you're basically using. You need to ensure that the right sized disk, which supports the IOPS and also has the right bandwidth, is what you use. Of course, the next thing is isolating the database files, the log file, as well as the temp file, because that's normal SQL Server 101. I mean, to manage your data files and to get the best IO throughput. And of course, then what we also have is you should enable the right caching for the right drives. For example, if you're basically using the data drive, for those drives, you can go ahead and enable the read caching. And for the log file, you probably wouldn't enable any sort of caching. So these are some of the things that you should definitely keep in mind. And again, most of these are by default set, so you don't even have to worry about them. And similarly, what you also have are where your TempDB should be. For example, if you are using a local thermal drives, those are best for the TempDB performance because you don't care basically what's stored in TempDB and you're okay when it is restarted. Similarly, you have write accelerators and accelerated networking, all of which are available. For example, accelerated networking is by default enabled for the Azure VMs when you're configuring. So basically using a marketplace image and using these best practices, which are by default configured, makes you write up and get going with SQL Server and RHEL without thinking about how you should be configuring it to basically get the best performance. So out of the box, you get the best performance to get started with SQL Server and RHEL. Now, with that, let's talk about SQL Server 22, because at the end of the day, this is the latest release that we have loaded with multiple features. So let's go ahead and talk about SQL Server 22. Now, as you all know, the SQL Server 22 release comes directly out of the box cloud connected, which means services like Azure Purview, services like Azure Managed Instance, or the Azure Synapse link, you can set them up right inside the SQL Server without any additional ETL jobs or anything. For example, if you want to set up a DR on Azure MI, all you've got to have is an MI already running in Azure, and then you can set up a link where there will be data that will be moved through distributed availability groups to the Azure MI instance so that it's available as a DR option for you. Similarly, you want to go ahead and move all of your workloads which are not OLTP related, anything related to analytics, you want to move it to Synapse. Again, you can do that real time through the Azure Synapse link. And you want to govern, classify your data, the Azure Purview service is right integrated in SQL Server 22. Now, I can talk about all these services as much as we can, but let me also cover the second segment of features that have been introduced, and that is related to the built-in query intelligence. Query Store by default is turned on. So that means you can now get all the benefits of Query Store without actually turning it on and then managing it, because it's all done for you. And this is because of the experience that we have had by managing the Azure SQL DB for our customers, which is already, which also has the Query Store enabled by default. And then if you are a DBA, I am very sure that in your lives you must have seen a day where you've gone back home and then you get a call saying that a stored procedure that was running fine until yesterday all of a sudden has started misbehaving, and you need to get back on the call and start working and start troubleshooting. You know what? All of this is now taken care in SQL Server 22, so you don't get that call, because now that parameter sniffing issue that used to be with the stored procedures, this is not going to happen for SQL Server 22, because now for each stored procedure, you basically can store more than one plan. So I'm sure this must give you some good amount of sleep that is needed as a DBA after a long day of work. And then what we also have are multiple enhancements in the scalability, security, and availability areas. And I'm just going to spend another slide talking about it. So I'll park this for some time here. And after which, the most important feature that I really want to spend some time, and I actually also have a demo about this, is data virtualization and support for object storage. Now, you've all seen that we've been working with Polybase for a very long time, and we've gone ahead and enhanced that further. And now in SQL Server 22, not only Polybase, using Polybase can you actually connect to external data sources, but you can go one step ahead where we now support the S3 object storage as well. For that means you can actually go ahead and take a backup on an S3 API supported object storage, and basically also restore your database from that over TCP. So that is another enhancement that we have. And to be honest, I'm going to spend another slide with a demo showing how easy it is to actually get started with object storage backups for SQL Server 22. Next in, what I basically have is the developer experience enhancement. For example, if you're someone who spends a lot of time with T-SQL, you know there were some functions that you always wanted. That could be related to time series, that could be related to JSON, that could be related to T-SQL. We have a plethora of functions that we've been added for SQL Server 22, which I'll be very excited to share in the upcoming slide. With that, what I want to talk about is the release notes for SQL Server on Linux and all these services that are supported. For SQL Server on Linux, most of these services that we spoke about, almost all of them are supported for SQL Server on Linux as well, including things like Azure Active Directory authentication, the MI link, the Synapse link, all of these features, the data virtualization, the T-SQL based snapshot backup, which is another feature that has been added, especially looking at the Linux platforms where you don't have the VSS kind of a framework available to take snapshot backups, but you have other services or other storage enhancements which you could do. So all of that is what we are going to talk about, and the release notes are available here in the link that has been added here. With that, I want to quickly spend some time talking about the deployment options. I mean, all of you know that today you can deploy this on Windows, on Linux, on containers, on Kubernetes platforms, standalone containers, on Azure Marketplace, using Azure Marketplace images. So all of those are supported with SQL Server 22, and all of the distributions that we've been working with, all of them are also added and supported. And you also have the SQL 22 Marketplace images coming in very soon. With that, I want to just spend some more time talking about the security, the scalability options. For example, Ledger, which basically brings in the blockchain technology right inside the SQL Server. From that same engine, you can basically keep a track of what modifications have been made for your table, and also understand that if there is any change that has been made, you can actually also integrate it with Azure Key Vaults to actually go ahead and see for every change that has happened. Similarly, you have a lot of enhancements that have happened in TLS 1.3 as well as TDS 8.0 settings. In the same area, if you look at the scalability options, now by default, there are some engine enhancements that have been done that could be under the buffer pool section, hands-free TempDB, where we basically will completely, you don't have to worry about CAM and SCAM and all of those contention areas that you used to see with the previous versions. All of this is by default built in. And similarly, when it comes to availability, you have cross-platform snapshot backups. And this is a fantastic feature, like I said in the previous slide, which is being introduced with specific idea for SQL Server on Linux platforms. And I have a demo on this as well. And of course, enhancements to availability group, where you can have now multiple T-SQL connections working for distributed availability groups, supporting between the primary and the forwarder, as well as contained availability group to move the instance level contents to actually your secondary replicas. With that, I think it's now time to quickly look at the data virtualization and object storage. Like I said, today, when you're running SQL Server or when you're basically having a data platform, it's not just subjected to one SQL Server instance or multiple SQL Server instances. You have an heterogeneous environment, and we totally understand that. And that is why from SQL Server Engine, we give you an option to basically go ahead and query all your data, which could be in the Parquet format, Delta format, CSV text, all of that data that's available on Azure Blob Storage or on ADLS. You can query them through Open Rosette if you just want to query once in a while, or if you want to query them multiple times and you kind of need statistics built on that, then you have options like external table or create external table as select, because you might also have a scenario where you want to query the data as well as modify the data before storing it in an external table. Now, when I say we are storing it in an external table, it's not a data movement that's happening. It's basically just creating a metadata that enables you to use the T-SQL functionality to be able to query it just like an ordinary other table that you would have inside SQL Server. And the most important thing that I want to talk here about is the support for the S3 compatible storage. Storage is like Ceph. You want to basically go ahead and use that and be able to connect or back up your databases or even create external tables on S3 compatible storages. You could do that today over HTTPS. I think this is best explained if we go ahead and take a look at a demo. So let's do this. I think we should go ahead and take a look at this in the next slide, which is basically the demo for the S3 backup and how you can basically use it. So let's roll the demo.
Welcome to this demo on SQL Server Backup to URL for S3 compatible object storage. So in this demo, we are basically going to show you how you can backup or restore in SQL Server with S3 compatible object storage. So the target is basically an S3 compatible object storage. As you can see on the screen, in this demo, the S3 compatible storage that I am going to use is the MinIO server. I've already gone ahead and configured the MinIO server and the portal. As you can see, this is the portal. I also have gone ahead and created a SQL backup bucket. This is basically the bucket in which I am going to store my SQL Server backup files. So this is basically the destination. Now, there are a couple of prerequisites that you need to remember for your SQL Server to be able to talk to your S3 backup storage. The first prerequisite is it is assumed that the communication that is going to happen between the SQL Server and the S3 object storage is going to be over TLS, which means all the transmission that happens will happen over HTTPS. And the second assumption is that the SQL Server will definitely have the credential details to be able to access this storage. Now let's go and take a look at the SQL Server that is running. So I already have a RHEL system configured. I've also configured the console access to it so that I can access my machine through the console, which makes it easier for me to actually also access the terminal. Inside the terminal, as you can see from this command, I already have my SQL Server services running. Also, if you look, I have copied the certificate that was used for the TLS setting on the MinIO server. That same certificate has been copied inside SQL Server at this location as shown here. And because I have this certificate now available on the SQL Server, I just go ahead and restart. And after the restart inside the SQL Server error log, you should basically see this message which says the client TLS certificate has been accessed, and you can see the path that is basically used. So this confirms that I already have the required public certificate, which is basically the certificate that is used for TLS. So the next step basically now is to go to your any client tool with which you manage your SQL Server and then run the backup commands. So here is an example of the same. So I've already connected to the SQL Server, which is running on a RHEL machine. And I'm going to now go ahead and create a credential which basically is going to be S3 as a prefix, which means this credential is going to be used to access the S3 compatible object storage. And in this case, my MinIO is configured at S3 SQL s3.sqlsample.com with the port 900. And I've also pre-created the bucket, as you have seen earlier in the console that I showed. And this bucket needs to be pre-created. You can definitely name it as per your liking, but this bucket needs to be created. And then I provide my access key ID and the secret that is associated with that access key ID. With these, I am going to go ahead and create the credential. Once the credential is completed successfully, all you've got to do now is to just go ahead and take a backup. Example DB is the user database that I'm going to use in this case. So to take the backup, I just go ahead and execute normal tsql backup command. And as you can see, the backup has completed successfully. I can also see this backup file inside the bucket on the console. So if I just refresh this over here, you should be able to see it. So let me just log in again, and with the same passwords, you should be able to see the file that we just created. Here it is, the example db.back. So it is very easy for you to get started with S3 compatible storage backups and restores for your SQL Server in starting SQL Server 22. With this, let's go back to our slides.
Perfect. After that demo, what we've now have to talk about is basically the T-SQL snapshot backup. Now, let's say you want to take a backup of a database, but you don't want to take the backup through streaming methods, because normally the streaming backups that you have in T-SQL that you can take is dependent or is directly proportional on the database size. The time to take the backup is directly proportional to the database size. And the other option that you can basically go ahead and use, or it is basically used heavily by most of our customers, is to take snapshot backups for very large databases. And you can take multiple backups for multiple databases using the snapshot within few seconds, because that's not proportional. The time to take the backup is not proportional to the size of the database. So in this case, for SQL Server in Linux, instead of creating a VSS kind of a framework, what we basically brought in as a new feature was an ability to basically go ahead and suspend all the IO that is happening on a database through a T-SQL command. So basically, you're preparing the database that there is going to be a backup that is going to happen, and for the backup to be consistent, you're basically suspending the IO, or in other terms, freezing the IO. And once you basically freeze the IO, you also acquire the locks that are needed so that you can go ahead and convey the message, or basically use a storage level service, which can then take the snapshot of your database files that are placed on the server. And once the snapshot has been taken, the next step basically is to go back and let the IO that you froze, you basically remove those locks and allow the IO to be back up and running again, so the database can be used for the normal workload. Now, this ability to be able to freeze and thaw the IO from the T-SQL basically enables any snapshot service to actually connect to SQL Server, take the backup, and then go back and inform SQL Server that the backup has completed. And for this, again, I have a demo that I want to show you, because demo would make it easier for you to understand. So you know what? Let's go ahead and take a look at the demo for the T-SQL snapshot. So let's roll the demo.
Hi, everyone, and welcome to this demo on how you can take T-SQL-based snapshot backups for databases in SQL Server 2022. As you all know, this is a new feature introduced in SQL Server 22, where you can go ahead and take a T-SQL snapshot backup. Now, to be able to do this, there are a couple of prerequisites that you need. First, you need to go ahead and freeze the IO that happens on those databases or on the single database for which you're going to take the snapshot backup. The second step is that you need to have underlying storage mechanism or a service available using which you can take the snapshot backups. After which, after the snapshot backup completion, you can go ahead and resume the IO on the databases by taking the metadata backup. In this case, what I'm going to show you is a SQL Server which is running on Red Hat platform, which is a Red Hat RHEL 8 server. I'm going to go ahead connect to this RHEL 8 server through the web console, as you can see on the screens. I'm using the web console because it makes the administration of the servers easy. I can quickly go ahead, create volume groups, move files, and also access terminal, which is the bash command, all just from one single window. That is why I like using the web console. So going back to the storage, what we got to do first is we are going to go ahead and create a volume group. So let us do that. I will call this volume group as SQL Data VG. Once the volume group is created, let me go ahead and use this drive. Once the volume group is created, all I've got to do now is SQL volume. And let's call this as SQL Data LV. And I am going to size this to, let's say, 9 GB. After I create this, the next step is basically to format and to mount this to a specific folder. In this case, I am going to mount this to SQL data folder, which is on the root. And as you can see, the file system that I'm using here is XFS because that's the file system that's also recommended for SQL Server. So as soon as I do that, I will have now. So if I just go ahead in the terminal, if I go ahead and access this via the super user and then list the logical volumes, you should see the new logical volume that just got created. At the same point of time, if I also list the volume groups, you should see the volume group that we just created. And if I go to the root drive and list the folders there, you should see the SQL data mount point also created, which basically points to the volume group that we created in the previous step. So now what I've got to do is I need to ensure that the SQL Server uses this logical volume to actually have all its user databases, because this is the folder of which I'm going to take the snapshot. To do that, I go ahead and configure SQL Server to use this particular folder by changing the settings in the MS SQL config. As you can see, this is the command. And then I will also change the log directory to point to the same folder. So I'm going to use this as the log directory as well as the data directory, which is not the best practice to do because you should always use different drives for data as well as for log. But because this is the demo, I'm just going ahead and doing that. Also, another important thing that we need to do is we need to ensure that the ownership of this folder that we created resides with the MS SQL user and group. As you can see, this is what I'm going to do now. So if I just list again, and you should be able to see now this folder is accessible by MS SQL user and group and also owned by it. So now I just go ahead and restart the SQL Server. Once I restart the SQL Server, the changes are now in effect, which means if I connect to the SQL Server and create a database inside this SQL Server, you should see the files, the data file as well as the log file getting generated under the SQL data folder that we created. So I can just go to the SQL data folder. And if I just list the files, you should see the files created here. So these are the database files that are created, both the MDF as well as the log file. Now, what I have to do is go back to my SSMS or any client tool using which you connect to your SQL Server, and then freeze the IO. Now, to freeze the IO, the command that has been introduced in SQL Server 22 is the alter database command. Here, I'm just freezing the IO for one single database because that's the only database hosted on that drive. I go ahead and freeze the IO, which means I am now ready to use the underlying storage mechanisms or any other service that can take the snapshot to actually go ahead and create the snapshot. So in this case, I am going to use the logical volume based snapshots, and The recommendation is you should always use the thin provision snapshots because you don't have to specify a size. Dynamically, things can be controlled. But for this demo, just to make things easier, what I'm going to do is I'm actually creating a thick provision snapshot, and the command for it is this. It's a very simple command. I'm just pre-creating a size with 1 GB. Also, this is the name of my logical volume snapshot, and the origin or the snapshot of which file or which logical volume I'm going to take, that's what I pass here. So this is the origin. And once I click on enter, you should see the logical volume group created, which is basically a snapshot of this volume group that we have, which is basically the one that hosts the SQL Server database files. Now, what I need to do is I need to create folder inside my SQL Server backup so that I can mount this volume that I just created. To do this, the command is as simple as make directory. And once I create this folder, I can now go ahead and mount the SQL Server files there. So this is how I would mount. So what I'm basically doing here is the logical volume that I just created, I'm mounting it to testDB SS1. So this is where I can see my files that I backed up. And once this is done, I need to also ensure that this is also owned by the MS SQL user. This is a reason in case if I want to restore, this path should be accessible to me. And now if I just go ahead and list the files present in this folder, you should basically see the the database files available here, which we actually took the snapshot of. With this, now we are ready to resume the IO on the databases so that the database can be used for the regular workload. And the command for this is basically running a backup database command with metadata only. As you can see, this is just the metadata that I'm actually copying. And I go ahead and execute this. And as you can see, this basically goes ahead and releases the IO and resumes the IO on the database so that now the database can be used for the normal workload. That's all. That's all it takes for you to create a snapshot backup, which is not proportional to the size of the database, unlike the streaming backup. And you are now able to use snapshot backups on SQL Server on Linux as well. With this, let's go back to our slides.
All right. After that demo, the next thing that I want to talk about or just spend just a few seconds about is the different features that have been made available inside T-SQL for a better developer experience. The first thing is the new functions that have been added under the JSON. Of course, then we've also brought in new functions that have been added under the T-SQL Gambit itself, and the time series. Now you could basically go ahead and also use the time series functions for SQL Server 22. So with that, I think it's time for me to hand it back to Lewis. And thank you so much. Lewis, over to you.
Thanks, Amit. That was great. That's really exciting news about SQL Server 2022 and lots of great features. And thank you for doing the demo of Red Hat storage as well. So with LVM there. So I did want to remind everyone before we move on further that we are going to have a question and answer session at the end. And I believe Tejas Shah from Microsoft is going to join us for that. So please put in your questions, and if you haven't already, and we will try to address them live during the session. You may actually see when you enter your question, you're not going to see other people's questions. So the questions are sent individually, but we can respond to a set of the questions at the end. So stay tuned for that. The last thing that I really wanted to talk about was RHEL 9, right? Because RHEL 9.1 has just been released. And I know that RHEL 9.1 for SQL Server 2022 is coming soon. And that by the time this recording is played, SQL 2022 will be available for RHEL 8. So that's pretty exciting news. And we, want to certainly make sure that everyone understands the advantages of running SQL Server on Red Hat Enterprise Linux. And this is really the mission statement of Red Hat Enterprise Linux. So this applies to RHEL 8 and RHEL 9. That Red Hat Enterprise Linux is your source for safe and reliable Linux innovation that makes your workload successful. And of course, one of those workloads is SQL Server itself. And really, when we look at RHEL 8 versus RHEL 9, both of them are focused around accelerating innovation. They're focused around streamlining IT infrastructure, helping you optimize. They're focused on, protecting your data and establishing a consistent security foundation. And they're focused on trust and helping you operate with complete confidence. Where they are different, right, is that RHEL 9.1 is earlier on in its cycle, right? We're talking about 9.1 versus 8.7. And so the life cycle of the major release of the operating system is different. Also, of course, the kernel is different in RHEL 9 from RHEL 8. And we're hoping to post some exciting performance numbers on RHEL 9 with SQL Server once, around the time that it's released. So, definitely get some extra performance boost. Between RHEL 7 and RHEL 8, we saw a big performance boost in SQL Server. I think it was upwards of, between 15 and 30%, depending on your workload. So that's pretty significant. And of course, we hope to see, advancements with RHEL 9 as well. So that kind of gives you an update of what's going on with RHEL 8 and RHEL 9. But we also, wanted to help you out with taking some next steps here. And so really, as we think about that, there are a number of sites here that can help you get going, right? You can get started with SQL 2022. I think the preview release notes are on the slides, but I believe by the time we actually run the video, it'll be the official release notes for SQL Server 22, and the official getting started guide for SQL Server 2022 on RHEL will be available. You can just run through that, though. You find the RHEL section, you run through it, and it will show you how to, do the DNF install or yum install of the package. It'll show you how to configure it and run setup, and it's really straightforward. You'll be up and going in 5 minutes. Of course, you can also use the system role, and once that is available for SQL Server 2022, and that once that support is there, you'll be able to do it in under a minute. So that's really awesome.
And of course, and then the release notes will also be updated with the new features that have been added, because by the time it is released, definitely there will be more features that have been added in terms of supportability for SQL Server on Linux. So in this link, if you're basically looking at the preview, there might be certain features which are not supported, but that will change when the GA is released.
Right. And then the other thing we want to think about is how you get up and running with SQL Server 2022 on RHEL in Azure, right? And we mentioned, Amit mentioned that there are images already there. I know that SQL 22 images will be coming. I'm not sure of the exact dates of those images, but that will be available up in Azure. And those will be both images that are, prepackaged, where you can bring your own subscription, as well as, images where you can actually pay as you go for a subscription in Azure itself. So you have either option from Microsoft. And then lastly, I wanted to point you to the Red Hat Enterprise Linux Labs, because you can get a fully running Red Hat Enterprise Linux instance and try out an installation of SQL Server. The Ansible system role, for example, is there, and you can use that to install a SQL Server. It'll be a little slower because you're in a virtualized environment and it's sharing a lot of resources with other systems. But you can go ahead and run that there and and get some hands-on experience. There are, I believe, 5 specific labs focused on SQL Server on Red Hat Enterprise Linux, and then really 7 labs that align with SQL Server, the SQL Server workload. So really recommend you look around there and think about how those labs might help you out, and how some of the technologies that it shows off might fit into your environment. With that, I certainly want to thank Amit for being with us today. And I want to thank everyone for their time, and stay tuned for our Q&A.
Thank you so much, and thank you so much for the opportunity. Really loved it, and thank you so much for your time.
We did have one question, and unfortunately the software wasn't allowing us to answer it. But I don't know. We have a URL for there is a URL for SQL Server
Right.
and for patches. So I didn't know if how we can get that up on the screen here, because it seems like there's some sort of filter preventing us from putting it.
Yeah, it just to give it it's the same link that they just gave, but in the search you could just put SQL Server, and you'll see all the SQL Server releases and the support dates and end dates for it. So hopefully that answers.
And that'll be displayed as one page once you do
Yes,
That's
in the
it.
search result, yes. In the search results, you'll basically see all the SQL Server versions and the support start dates and end dates.
And it will allow you to download, export, and download for your reference or sharing as well.
Yep. Were there any other questions that people had today? I know one that I've heard a lot is, pretty consistently is, what are the differences between running SQL Server on Windows and running SQL Server on Linux and running SQL Server in the cloud? And, I think, that's one that we'd love for you guys to answer today. So we'll give that to...
It's a very good question, actually.
Tejas.
And to summarize, from the SQL Server perspective, it is the same SQL Server running on Windows and Linux. It is literally the same binary running on Windows and Linux, which means that overall the functionality remains the same. There isn't really all that much different about running SQL Server on Windows or Linux. Just a question of the environment. Obviously, there is going to be some dependency on the environment, like how the storage is configured, or how operating system is configured, how the folders are created to host the databases or the backups, etc. So wherever you have the little bit of a dependency, those practices of administration might be slightly different. But running SQL Server, especially if you live in the SQL Server itself as a DBA or a developer, that basically is identical whether you run it on Windows or Linux. And I saw another question in the chat which basically asked this question as to can we run it on premises and in Azure? Yes, SQL Server you can run it on premises, in Azure, on Windows or Linux, in a Microsoft cloud, in other clouds. It's you can run it as a VM or a container. It's essentially we are trying to meet our promise, where we basically said that we will meet you where you are, whatever your requirements, whatever the platform that you choose, whatever the kind of ecosystem that you want to play with and live in, we will find a way to meet you there. So we are just meeting our promises there.
Yeah, and we have some great examples of that at Red Hat. In fact, we have customers where the DBA is more comfortable with a virtual machine environment, and the developers want to develop in a container environment, and so they're using OpenShift as their container development environment, and then using OpenShift virtualization for production. And that gives them the key advantages of a virtual environment for that production environment that they're comfortable with, while they're still able to use the containers for their development processes. So there's a lot, that same compatibility that Tejas was talking about between Windows and Linux, it also travels between containers and traditional deployments as well. And we see customers using that, in the real world. So that's very real for us. If there are any other questions in the Q&A, I haven't
Yeah, I mean,
seen
basically,
any.
we wanted to make it a no-brainer. Where you want to use SQL Server, as long as you want to use SQL Server, it doesn't matter where you want to use it. Containers, Linux, Windows, wherever, it just works.
All right. Well, it doesn't seem like we have any other questions today. I want to thank everyone for your time, and be sure to have a great day. Thank you.
Great. Thanks, everyone.
Thank you, everyone. Take care.